Well, howdy, y'all, and welcome back to another high-powered episode of High Voltage Live, the most electrifying show on social media. I'm your host, Willie Snyder, bringing you this podcast from the Mile High City in Denver, Colorado. I am joined by my awesome partners in crime over here, the Stallcups, the combined most awesome electrical teachers of all time, hands down. They're in the wall of fame for all time, best teachers ever. James has the best training online you'll ever see, and senior, I'm very glad you're going to join us again, sir. And he has the best publications. If you see a publication that's a Stallcup on it, you know it's good, and it's because of you, sir. So it's very honored to have you guys.
Yeah, it's sort of funny. The last three guests we had on, they all showed his book.
Yeah, absolutely. That sent chills down my spine because they're like, yeah, guess who we learned from? We learned from Pops.
Well, I did a post the other day. I was saying, we had over 80 years combined teaching experience, and I think he was 70 of it.
Yeah. Yeah.
I said, I did a post where I said we had over 80 years. I said, I think you were 70 of it.
Or more.
Or more.
Yeah.
Been around a long time.
It's really awesome to have your guys' experience in here. I want to give a big shout out to the NEC for Dummies group. We're at 13.5. Really awesome. Great week for us. We picked up like 1,000 members, and it's so awesome that everyone's joining in with us, and we're able to have fun together, and we're able to go to these top code experts and ask them questions and get some really good answers and get the charging language of the NEC out there and, figure this out along with my Nat King Code page. I'll tell you what, I give all my Nat King Code followers A+ this week. Everyone got it right. Everyone did a perfect job on this week's myth. It was really awesome. I had a lot of fun doing it. This is one that's just always going to be around, and we're going to just keep going through it. But,
Sure.
One thing that we want to bring you is we want to bring you not just our opinion on what we think. We want to bring you what the code language actually says and say, hey, if your inspector's interpreting it this way, that's fine. That's up to them. But it's up to us to educate people to try to figure out, hey, this is what the code language says. Are you sure about that, inspector? And I've actually won a lot of battles with inspectors because they want to learn too. And I want to give a shout out to Fort Collins, AHJ. Really awesome. They've done a really awesome job on our job, and they're always trying to learn and stuff. So
that's funny you say that because Dad, you were there just couple of months ago, wasn't you, in Fort Collins? Or
it was probably
about 3 months. Yeah, he was just up there doing a class at Fort Collins.
Nice. Yeah, the Fort Collins AHJ. He come up in the morning and he says, "Man, somebody teach me something." I says, "I'll teach you something." And I was like, about 41069, and so it was pretty cool because that I learned that from your training class on the Colorado CEUs. So It's really awesome to watch this stuff go full circle. Another big shout out to the Rebs group. We have a lot of electrical contractors that are members of the NEC for Dummies. And if you want to get like tips and stuff for growing your business and doing better at business, there's nothing better than the Rebs group over there. Just type in REBS on Facebook and it'll take you over the group. And They have a live stream on Wednesdays, and they do a great job on teaching you how to like niche out in your industry. And when you're able to go in and niche like code like the Stallcups have done, then it'll make you a good living, and you'll look like a bunch of rock stars at the end. And that's what we're after.
I was going to tell you, I was looking, we're actually at 13.7, about to go to 13.8.
Wow.
Anyway, let's go ahead and let Dad get started. He's got somewhere he's got to be, so we're going to switch it up a little bit and let him do the topic of the week. So when you get your audio going, we have audio for you now.
All right.
Here we go. All right. Dad's going to go ahead and do topic of the week, which is going to be
right.
reverse fed transformers. And the thing that's going to be cool about this, he's going to do this whole presentation with just one illustration. So everybody sit back, enjoy. I'm going to get out of his way and let him do his thing.
Nice colored illustration, by the way, sir.
Thanks.
Well, good evening to you folks out there. I don't know about you designers and installers, but around this Metroplex in the last year, we've seen an increase where a service for, say, for a little industrial type site or commercial small, they would have a 120, 208 three-phase four-wire system, but they would buy some 480 volt equipment, either, somebody going out of business or whatever. And instead of changing the service out or bringing in another service that would be 480, in accordance, with 230.2 of the NEC, they would take a separately derived system of 250.30. And if you think about it in this terms, they would just turn it around, just kind of turn it around, and they would feed the 208 volt side from the service equipment, 120, 208, and leave out the neutral. And then they take the 480 volt side and either corner ground it or run it ungrounded with ground detectors and the relay systems that they set up for protection. And they would, feed the equipment. It may be one piece of equipment or two or three pieces of equipment. But they'd have sometimes these transformers, they'd have maybe one in stock, in their storage facility and so forth. But in doing this and getting started, we'll be on about page, I think, 346 if you have your NEC and you just happen to want to tag along with the NEC. If you go to about page 346 and look at 450.11b as in boy. Some of you out there, until the 2014 edition of the NEC, then, reverse fed transformers wasn't necessarily recognized in the NEC. If we design and install one, then we had to naturally get with the authority having jurisdiction and kind of show them our outline and diagrams and just exactly what we were trying to do, and then get the authority having jurisdiction to give us an approval on it or whatever they said, we needed to do in addition to our design, installation, and layout and so forth. But one of the most important...
Do you mind if I ask a stupid question here, sir?
No, go ahead.
So now is there going to be like a code violation of like 250, I believe of 5031 for not having your entrance, your primary side with a grounded conductor? What is the concern that comes?
No, because you're looking at 450.11b for this reverse fed transformer, and it just says that you have to, as you're familiar with it, you have to contact the manufacturer.
Okay.
And then the manufacturer is going to tell you if you have any losses in voltage on that 480 volt side, on account of the way you're going to supply the 208 volt side. Okay. And are you going to have any amp losses? And then you have to talk to the manufacturer to see if they even recommend you backfeeding their transformer at all. They may not want you to do it at all. See?
Now, is there a way that you maybe could increase the size of your primary side on like say your 208 side to try to have less losses through the impedance of the transformer coils?
Oh, there's things that you could do if you want to go into spending the money for it. Yeah,
Okay.
but usually what they do, they just make sure that the transformer that they purchase or they have in stock will have a KVA rating large
Oh,
enough
gotcha.
to supply their load. But yeah, there's things you can do, but it costs you more money.
Absolutely. Okay.
And so usually
to
what
interrupt.
I've seen, and some of the designers and installers listening, that they can put their input in, but most of the time it's just an economical thing. Does it cost more to add a 480 volt service and get the authority having jurisdiction in the utility OKIT in 230.2, or is it just cheaper for him to use a separately derived system to do the job for him? So
Right.
usually what I've seen, that determines what they're going to do.
Okay, gotcha. Right
Okay.
on. Thanks for answering that question.
Okay, anything else, well, holler and I'll try to answer it.
Absolutely.
If I don't know
sir.
the answer, I know where to get it.
Oh yeah.
But
I know you've
all
been
I
on the
got to do
board.
is ask James. Hell, he'll tell me if I do something wrong here.
He's
So.
learning.
But okay, we'll get back now. Note 3 is important. If you look at the note in the illustration, you let the XO float. It does not connect to chassis ground in any way. It floats. Because if you bring a neutral in and ties there, then you're going to pick up all unbalanced currents. Any kind of ground fault and things can travel back over that conductor. So it does release a lot of unwanted energy from that 480 volt side coupling through the ratio to that 208 volt side. So they said, no, leave it float, and then bring your equipment ground in and bond it into the chassis. See?
Right.
Now, this primary side, and when I say primary, it's the 208 volt side. I'm just using it as that.
Yep.
You usually have to size the overcurrent device larger than table 450.3b will allow for inrush current. Your inrush currents, can be up as high as 37 times the full load current of the transformer when you backfeed it.
Right.
Now, it's not always that high, but places I've seen it, it's up to anywhere from 25 or higher in most cases. And of course, you can figure that, if you know the resistance of the windings here, but you have to know the resistance of the windings, and you can get the, peak current by taking 1.414 times the voltage and divide it by the resistance in the windings, and that'll give you your peak current. Then take that peak current and divide it by the voltage of the transformer, and that will give you basically the inrush current. And I am going a little fast, but if you wanted to look at our transformer, generator, motor book, or our design book, then all this information is in there that I'm going over with you. I'm just taking some of that and then some of what I'm seeing out in the field of designing engineers and electricians, installing these things. So again, now we want to figure, this is a feeder because we know the definition of the 208 volt side here. That is a feeder. So we'd go to 215.2A1, A or B.
Right.
And we take 125% for the continuous loading here. And then, of course, you'd look at the temperature. But most of the places that I see these installed, they're installed in an area where the temperature never exceeds the 86 degrees Fahrenheit of 310.16.
Okay.
Now, if you have your code book, everything that we're going to look at will begin on page 157 up to 160. And right in that area, all the sections that I give you, here you can look it up if you want to.
Nice.
But a lot of times, if they install this transformer where the temperature could exceed the 86 degrees Fahrenheit, Then they have to figure that by that table 310.15 B as in boy 1. And usually, you know, it's if you go over to 310, I believe it's 310 dot 15 B, and we look at the exception over there, then it's a 10-foot or 10% routing.
Right.
In other words, if you routed it, say it was 100 foot from where we connect here back to the service equipment, then you take 10% of that, see, that'd be 10 foot. And if you only routed it 90 foot and you only had 10% of it, of the 100 routed through there, and you didn't go over 10 foot, you know, you're not going to have to derate at all. So
Gotcha.
again, you can find that over between page 157 and 160 in your NEC, this information.
Well, and I could see this being a big deal. Like if you're exceeding the 10-foot tap rule on 208 bolt when you're in this reverse fed situation, it might be a bigger deal than if you do exceed the 10-foot tap rule on 480 bolt.
Well, you're going to have to apply that over here.
Okay.
You're going to have to apply 240.21, and you'd look at C2, and that's the 10-foot tap.
Okay.
Gotcha. And if you look at 240.21 C3, then that is over 10 foot to 25 foot.
Right.
And that's an industrial tap.
Okay.
So you get that 250%, you know, on this primary side if you wanted it from table 450.3B. Okay. But then if you want to have a commercial tap, well, you guys know that's 240.21, and you'd look at the 6 there that we would look at, the exception 6.
Absolutely.
And that would give it to you. And then if you was in a supervised industrial location, is defined in 240.2 of the code, then you could be over 25 foot up to 100 foot by 240.92C, as you know.
Unfortunately, it never worked in supervised locations. I'm always unsupervised, so
yeah. Well, a lot of times people are, because you know when you look at that, you're going to have engineering supervision. You're going to have a supervisor to ensure that all people are qualified to work and service on the unit.
Yep. And what makes them qualified?
Well, what makes you qualified naturally is OSHA. You'd go to 1910.132B1.
Yes, sir.
And B2, and that qualifies you as a qualified person under engineering supervision and supervision of the industrial site. Yeah, but that's where you go to get that you get the training in line with OSHA, because it's really outlined good.
A lot of guys say it's a journeyman license. That's why I was making a joke about it.
No, a journeyman license now is state, county, or city. OSHA does not require any kind of licensing. They just say you have to be qualified by that section 1910.132B.
And I would add that you understand the equipment that you're supervising.
Well, you know, through the code, and some of you guys that are out there and ladies that are code bugs, you know, we, through the revisions of the code, we made everything qualified for journeyman. If you're, say, an engineer, then you're one of 3 ways. You design the system and you're done. Or you design the system and you have to supervise its installation, 2. Yep. And then 3, you have to be a registered engineer with the state where you make your design. And so they look at an engineer that way.
Okay.
But a journeyman electrician, OSHA says you got to be qualified. But I like to look at 1910.132B. You guys out there probably, and ladies, know this, but you can type in OSHA.government and their site will come up. And then just type in OSHA 1910 subpart S, and you can get all this information. Every bit of it. Right
and
there.
To me, just to tell all the listeners out there, that's like the holy grail of all the safety, what we do.
What did you say? I didn't hear that. Well, speak up. I didn't hear you.
I just basically said that's like the holy grail of all the safety that we deal with, regardless, whatever it is. You know, it's
Oh,
just
okay.
that 1910 is a kind of the holy grail. You know, is
Okay.
what I'm saying.
Got you. I'm sorry I didn't hear you. I'm
Yeah,
sorry,
no,
Bill.
it's absolutely. I'll shut up and let you teach. I'm one of those bad students.
Okay,
Ask too many questions.
so mainly this side 208-volt side here, you're going to size them overcurrent devices larger than table 450.3b due to the inrush current of the coupling of 480 to 208, which is about 2.3, something like that. So you're going to get high inrush current over here. And then you have to size the overcurrent device so that it will hold when you energize it. And in any time that you hear any kind of inrush that you would have, it'd be large just to take care of it. But then you don't have any overload protection. So how are you going to provide your overload protection? So you've got to look at that and make sure that you take care of that, see? Because we know we protect the conductors by Article 240, don't we?
Yes, sir.
Article 450 is only for the transformer. And until the 2014 edition, 450.11b, again, was not in the code. So when we install this, and I've installed them before, you had to check with the authority having jurisdiction and get those rules. So now, kind of going over then this 208-volt side, we kind of taken care of that. But now, note 1, the primary side is connected to the load, as we see. Note 2, the secondary side is energized by the supply circuit from the service equipment here.
Okay.
And then when we look at note 4, always check with the manufacturer before making this type of hookup. And then, of course, that's 450.11b. Now, going to this side, which, Bill, you talked about, you apply your tap rule.
Yes, sir.
And if you design it by engineering supervision, engineers doing the job, if you can size any length of these conductors you want.
Yep.
Any length. When you look at 240.92E as an ed.
Yes,
we
sir.
can pick that up. So those are the taps that you make here. And if you go over 25 foot, then you're going to be over in 240.92 C or E.
Okay.
So you got to be careful, that, or set an overcurrent device and start over,
Well, and I would argue that I would agree with you that when you're checking with the manufacturer's instructions, my myth of the week topic this week was based on 110.3b, that you always follow manufacturer's listing and labeling of instructions.
That's correct.
And so that's a big thing on this show that we're trying to push as our actual topic.
Yes, you always got to satisfy the authority having jurisdiction where they have jurisdiction and power. Yeah.
Yes, sir.
Yeah, that's true. And then you do the same thing about routing these. If you route it through a temperature higher than 86 degrees Fahrenheit over 10% of the run, or 10 foot, whichever gives you the calculation, then you would need to derate. But you don't have to worry about any of the conductors being, over 3 current carrying, because we only have 3 here that's going to be current carrying. And you can corner ground it here by 250.26, and I believe it's item 4.
Nice.
In 250.26, item 4, that recognizes corner ground. And of course, you're going to measure 0 voltage to it, aren't you?
Yes, sir.
Just like it was a neutral, see.
Mm-hmm.
Or if you don't want to corner ground it, then you can look at 250.21 and go through the sections that deal with this ungrounded system, and you'd use grounding relays. You would use another relay system or some system, or where you terminate it, you would protect the conductors from overload, if you say.
Yes, sir.
But you would look at the 450.21 for that. Then you have to have a plaque saying that you're running it ungrounded.
Yep. I
So,
would.
but I've seen more of this being done, and it's mainly where you would have a 120, 208 volt, 3-phase, 4-wire service equipment system, and you don't want to, put in a 480 volt service, which you could because it's different voltage by 230.2.
Yep.
But if you can save money doing this, I'm seeing companies do it more. And I think that's one reason that they added it in the 2014 and put it in 450.11b to recognize it. But you notice
Nice.
in the 2020, there's not a lot of information there. They're just telling you go to the manufacturer, and then you would apply 310 for conductors, 240 for overcurrent protection, setting them overcurrent devices for 50.3b, or the amount of inrush current throughout the run. So you do have some problems when you make this type of installation.
Right.
And you got to be on your toes because you have to protect the conductors after you select them. You have to ground it properly and those kind of things. And here we're just showing you basically here how we would feed it and everything. So, but on this side over here, they usually will take that to ground like you see there. And ground it just like in accordance with 250.30. But it's a reverse fed type transformer. And so, some of you designers and installers out there, if you haven't already run into this, you may run into it. So just kind of be aware of it and know that it is, you may already know it. I'm not saying you don't, but recognize it. And if you can save your customer money, or they want you to do it to save money, then you'll know where to go in the code to look this stuff up. Not that you already don't know that. I was just throwing this up, and James and I thought this would be a good one to go over with you and cover the sections you need to look at. In D rating, we had a question that come in that was interesting. The person wanted to know how many ampacity derating procedures could you have where you had 4 more current carrying conductors. Well, if we go to our table 310.15c, around page 160, that's the most restrictive, isn't it? We've got to reduce ampacity of the number of conductors that we pull in the conduit. But if you went to table B.211 on page 725 of your code book, and you had, say, 16 conductors, and you only loaded 8 of the 16 at one time, any 8 you wanted, it'd only be about 70%, wouldn't it?
Okay.
And if you wanted to do the calculation where you might have, say, instead of having half 8, say you wanted to load 12, then you'd go to B.7a on page 717 of the code, and you'd run that formula there, and you could load more than half of them, couldn't you? And then the only other way you could do it, before and all, you could go below the table, 310.16 there on page 160. And if you had 16 conductors in the raceway and you only loaded 8 at one time, then you take the highest D rate for any 8 and use that. And then you could load them that way, couldn't you?
Hey, one thing I wanted to tell you, Senior, that I really enjoyed about kind of the way that I went through this process. Do you want to know what the transformer manufacturer would say if you call them?
What they would tell you?
Yeah, I could tell
some
you.
of them would tell you no.
I could tell you the exact what they would say exactly.
Yeah, a lot of them will tell you no, that they don't want their transformer backfed. And then some of them say it's okay long as you follow the code sections that regulate it and get it approved by the authority having jurisdiction. There's some of them that say you can, but there's a lot of them that says no, you need to actually get you a step up higher voltage transformer. But they don't stock those. You got to have them usually manufactured. So that's why
So
they'll take a lot of this reverse fed type transformers, because they can do that immediately.
I am actually the poster child for stupid calls to customer service. I call customer service all the time for stupid things. And I called and I asked them, I said, hey, what do I need to do on this transformer? And they say, follow your local code, sir, and hung up on me.
Yeah, and but they usually will tell you, yeah, it's okay to backfeed this transformer, but it is up to the designer and the installer to find out, if you do reverse feed, is there a reduction in voltage that the transformer would put out?
Yep.
And then is there a reduction in the amps that it would supply? Because it would, a lot of times it won't be like before. If you took, say, a 100 kVA transformer and divided it by 480 times the square root of 3, those amps come out right. But when they backfeed, it doesn't always. So,
Oh, wow. Okay. I didn't know that.
yeah, it doesn't. So you'll have a drop. I've seen it drop down. I just here a while back, I looked at a fire pump, and the losses in this reverse fed transformer were so bad that they couldn't start the fire pump.
Wow.
And so you can get into that kind of thing, but you just need to look at those sections, and if any of you folks run into it, just start there on page 157 and go through pages through 157 through 160, and you'll pick up all your information right in there, except for 240.21. And you would have to go where and pick those up naturally. But
Nice.
But again, if you get into any of these problems, you're just going to have to design it. You're going to have to look at a number of sections to do it properly. But,
Well, and I do want to give a big shout out to you, Senior. You got a YouTube channel called Hot Topics. He has like the best hot topics out there. He did What Is an Outlets on there. He did a lot of really good stuff. So you guys need to go subscribe to James Senior's channel. Is it on Gray Boy?
Yeah, it's James Gray Stallcup Electrical Training Institute
Nice.
on YouTube. Yeah.
Okay. And like I say, I watched all your stuff. I shared them to our groups, and it was really awesome. You were really in depth, very thorough, and we really appreciate your, your influence in the industry is nobody's equaled it.
Well, I appreciate you guys listening. And again, if you wanted to go through a reverse fed transformer in depth, just type in James Gray Stallcup on YouTube, and you can go through a reverse fed transformer in great detail and go through all this stuff I've been telling you.
So you actually covered this on Hot Topics?
Oh yeah.
Okay. Cool. All right, I gotta go check it out. I didn't even know that. I'm gonna check it out.
Yeah, it's on there. We put
Nice.
it on because we had so many people. Well, I wouldn't say a great number of people, but we did have some folks calling us wanting to know about this reverse. And one guy had hooked up that XO, and boy, he was having hell.
Wow. Okay.
Yeah, he was having all kind of trouble. But
Okay.
but if anybody wanting to, review the video, we're going and do that. And again, Bill, I thank you and James for having me on. And
Dude, we love having you on.
Too bad.
Dude, we love having you on, man. We love
Hell
it.
yeah, we do.
There's one other thing. If you install one of these transformers in a place that has some high temperature, just feed and use the wire XXHW/2. It has that high temperature. and you
Okay.
won't have any problems with it. I've had a guy did it, and he said, hell, he hadn't had any problem at all. He was a designing engineer with Walker.
Nice.
So you
That's
can
good to
kind
know.
of keep that in mind. And thank you
Yeah,
again for having me.
I've installed some of that in a freezer that was 13 below, and I haven't had any problems either.
Yeah, it does a good job. Anytime you can put it on the roof in Arizona and it does the job, you know you're okay.
Yes, sir. Dude, I'm very honored to have you on, sir. Very honored.
Well, it's my pleasure to be here, and thank you for having me. And I hope you folks out there enjoyed the presentation on the reverse fed, back fed type transformer. Thank you
Dude,
again.
You're a legendary teacher.
He only said, only thing he's got a comment on is don't, for me not to be talking after this is over because he wants to go eat.
That's right.
See?
All right. Well, hey,
said, you're going to eat with me tonight.
he better go get in that bath. He's got about an hour left. No.
Well, I'm gonna go in and have something cold.
There you go.
Guys have a good meeting, and thank you.
All right. Yes, sir.
Thanks, Dad.
Thanks for joining us.
Awesome.
Yeah, that was good.
Yeah, he was telling me that he goes, now being there talking all night, he goes, I know how you are. He goes,
Dude, he's the one that you can't start the show and talk too much. You're telling us you better keep the freaking keep it real. So we gotta do myth of the week.
Yeah, let me cue it up and we'll get it going, brother.
It's time for Myth of the Week.
All right. Myth of the week.
Yes, sir. All right. No, this is awesome. So I don't know. Am I still muted or am I?
No, you're not muted.
All right. So this was really awesome. This was a 3.5-inch conduit that went to a chiller, and they're using an unlisted transition fitting. This is outdoors. So to me, it's really to call this code compliance pretty hard.
I'm with you.
Yeah, like if you look at how it comes up in there, I don't see any other way they could do it, but they actually make a listed transition fitting. You might have to skip through some slides that show that listed transition fitting, but
Sure.
I think there is one in there. Like if you skip through a few, I
Yeah,
think I got it in there.
We got quite a few different.
Yeah, there it is. So that's the listed transition fitting. That goes from EMT to seal tight. It's got the blue on there, and that's listed. So that's listed as a transition for like a wet location. And then this is funny. This is a transformer out in gas and oil. And this comes into the conversation. Okay, you could use seal tight if flexibility is necessary. Okay, well, where's flexibility necessary there? Like that transformer ain't going nowhere. And look at how crappy that looks. I mean, to me, I told them, I was like, why don't you just run the rigid right into the transformer? They're like, no, you can't do that. It's because vibration. Okay. And then when I started questioning on it, they're like, well, it might not be vibration. It's because if we have to remove the transformer in 27 years, we can take it out, And I'm like, dude, there's no reason why you can't just take a lock ring loose or take a Myers hub loose and pull it out of the way and remove your transformer and put it back. To me, it's weird. Like if you go back like a few slides, James, to the UL document. So this is a UL document, if you guys want to know more about the UL listings and stuff, you have to go to a new website. And, basically this is just like a product spec out of the white book. The white book has been replaced by a website called Product IQ. So if you go to productiq.com, it'll actually give you the listings of whatever you're installing. And then you can tell if they've been like listed together to be used together. So this is really interesting. I mean, to me, James, the first part really blew me away because it references nipples. How do we know what a nipple is? Like, is that 24 inches or less? I mean, what, like,
I've already
okay.
told you. Chapter 9, Table 1, Note 4. It tells
Okay,
you.
so all right, it's a nipple. All right, whatever a nipple is. It's not defined there, so we have to go to the Merriam-Webster's dictionary, and I don't think you guys want to know what it says on that. So then you go over to fittings with internal female threads, i.e., hubs, conduit bodies, couplings, have only been investigated for use with threaded rigid conduit. So that's telling me that threaded rigid conduit is only designed for conduit bodies, couplings, bell boxes, all that stuff. And here we're just throwing, EMT connectors in there willy-nilly, no big deal.
Right.
And to me, I don't really see that as a real world issue. I mean, I've done it a million times. I don't see any problem with it, but it is technically a code violation. So if we go to that next slide, James.
Got you.
So here's one that I seen. It was in a school and it's all painted and everything. I guarantee the paint's holding this thing together. I mean, there's no way that thing's coming apart. I tapped it with the hammer a little bit just to see if it was loose or anything. No, it's tight. So that comes into my next point, that basically, regardless if it's listed or not, per UL, per NEC, whatever, it's made wrench tight. So to me, that's where I don't really see a real world issue, because you're taking that galvanized rigid coupling, you're twisting it as hard as you can into that EMT connector. Then you're putting that flex connector as hard as you can into there. And then the school goes in there and they paint it black. And then, you know what I mean? That thing's not going anywhere. I mean, it's never coming apart. But that's technically, per the code language, not a listed transition fitting. And then on the right is a wire mold one, which I thought was really funny, because there is actually wire mold connectors that go directly to conduit. So that's why I thought that one was funny, because when you look at it, they actually have a connector that has the EMT going into wire mold on it. Right. And so they didn't have that. So they just made this. And to me, that's fine. It works. And like I say, again, the paint's all holding all that together. But in reality, that's not a listed transition fitting.
Sure. It's interesting, when you were first asking me about this stuff, you were asking me if a transition fitting could be used as a pull point, and I said no.
It was highly contested.
Yeah, and you said, why is that? I said, because you were quoting 300.15 to me, and I said, no. I said, that's talking about the fittings. Like if I'm looking back here, let me go back one, and I'm looking right here, and I had a Flex 90 here where you could take those screws off there, then you have access to those conductors. Yeah. That's a pull point.
Yeah, so you couldn't just put drywall around that transformer, because you'd never get access to that pull point.
Right. And then the other thing that was interesting, I saw you had posted a picture for Myth of the Week and everything, and I was just sort of waiting, and I put a comment in there. I said,
so go back to that picture for Myth of the Week. So in case anybody's joining late, they could see. So when we did this one,
are you talking about the conduit with the non-metallic sheet cable?
Yeah, just go back to that picture.
It's not on here. It was in the video portion.
Oh, okay. But anyway, that picture right there is actually going to be our next Myth of the Week. Not really that picture, but just that's what we're going to do. That's going to be our next myth. So
Okay.
every week we bring a new myth. And the thing is, that's funny is people say Romex can't be in pipe. And to me, there's a lot of variables there. And one of them comes down to the less than 10% of the run. If it's less than 10% of the run, I don't know exactly how this comes down, but the thing is that if you go into 358, it tells you have to protect that non-metallic sheet cable from damage.
Right.
And the only way to do that's with a raceway. So you have to put it in a raceway.
Yeah, we'll go full bore on that next week.
Yep.
And but looking at this, when you had told me that, I made a post and I said everybody needs to watch this week because there was a change in the 2023 NEC proposed text. And if you look at the language that they added in 300.15, you'll see where I have all the highlighted new text in yellow. And in that third paragraph, if you look down there, it talks about where you have wiring methods, and it consists of conduit tubing, type AC, type MC, type MI, non-metallic sheet cable, or other cables. It says a box or conduit body shall be installed at each outlet point and so on. But the one I want to get to is the wiring method transition point.
Right.
That's a big statement there. So,
well, I could tell somebody must have been paying attention to my posts because I've been driving this for a long time.
Yeah. And so when I looked at this, I went in the wording and basically I'm going to read the last part of the comment that's there that we put together. This is exactly what you will see in the type of text that will be in the 2023 NEC illustrated change book we always do. And matter of fact, before we started this, Dad was showing me the illustration he did for it. And I said, that's exactly what we want to put in there so people understand what's taking place. But what it says here, the wording wiring method transition points has been added to the end of the new language to provide direction on handling installations where wiring methods change from one type to another. As wiring method transition fittings are covered by section 300.15F, this type of point in the wiring system must be included in the charging language, which is I just looked at in section 300.15. Then it says, if the wiring method transition fittings was lost from being covered in that charging paragraph, then they tell you here, the enforcement of wiring method transition fittings is being listed for the wiring method they are used with will no longer apply to these points on the wiring system. That's a big statement. So when you look at this, I decided to go and prove my point here and why they made this change. Now, right here in this next one, this was submitted by Russ LeBlanc. And you'll see I have the public input here, exactly what 300.15 was to me.
I want to give a shout out to Russ LeBlanc and EC&M Magazine. He does a great job. And he's featured some of my pictures that I posted for code violations. And we really appreciate all the work you're doing, sir. And so big shout out to you, bro.
Sure. He's doing an awesome job. I know Russ. And
he actually wrote a code. I featured a code on Nat King Code. I was doing journeyman exam questions, and it was something about if you could run a light in a luminaire in a bathroom with the ungrounded, and then he actually wrote the code language that said you can do it as long as its load side comes off of GFCI. So I really appreciate knowing all this stuff when I go in there and I start meeting all the people that wrote these codes, and very intelligent individual, very awesome. Be part of all this.
Right. And what he did in his substantiation here, he's talking about the revised wording in that third paragraph we were looking at. And he says it's needed to clarify that termination point is referring to a conductor termination point rather than raceway termination points, and pull points is referring to conductor pull points rather than raceway or cable pull points. And that's what I was trying to say. is one is where it's a raceway termination, and the other is where you would have access. You could take the cover off, and that would be a pull point. And that's
Yep.
why I've always said it's not a pull point when you ask me this question. So
Yep.
he specifically does this, and then he gives an example in that second paragraph, and he says, many installers, inspectors alike are requiring transition fitting, such as EMT to FMC changeover fitting, to be accessible because the original intent of this rule is not known or has been forgotten. And
yeah, he was passionate on that. I think we drove that one a little bit.
yeah,
I want to give you a shout out to Russ. I did steal a few of your pictures.
yeah. And see, he says prior to the 2022, the words termination point did not exist in this section. It says it was never intended to apply to raceway terminations or raceway junctions. It was always intended to apply to conductor terminations, conductor splices, conductor pull points, and conductor junctions. Yet it is often misapplied. So watch this.
Yep.
He comes down here and he goes through a bunch of examples here. I'm not going to go through all of
dude, he worked his butt off on this. I didn't see
Yeah, he
this.
did.
Yeah.
Now, the part I like best is right here, okay? Because he tells exactly what his intent is here. He says, I'm acutely familiar with the issue since it was my conversation with Robert that had caused him to submit this proposal. Since 2002, taping the ends of the conductors of an abandoned but live NM cable are considered conductor terminations and would generally require what? A box. Okay. Then he says the revised wording will help clarify the intent. This revision will also help make it clear that a changeover connector is not being used in lieu of a box or required to be accessible in accordance with 300.15F, since it is not a conductor what? Pull point, conductor termination point, or conductor splice point. An example of a fitting that would need to comply with 300.15F is a 9-degree FMC connector, flexible metal conduit connector, where the back of the connector can be removed so it can be used as what? A pull point. And that,
hey,
what is
I don't mean to interrupt you, but we got Spartan Electric in the house, brother. What's up, Curse?
Hey, Spartan, what are you doing?
Yeah, he's a
William
G.
Curse, baby. Now,
yes, sir.
If you look at this, he is specifically stating, before I even saw any of this in the change, you had asked me this question, and I said exactly the same thing that Russ is saying right here. And I specifically stated, I said, it's not a pull point. And I know there's somebody else out there that said it was a pull point when you had that fitting there. And I said, no, I said, it depends on the fitting because you got to be able to take something off to get to the conductors. You know, I saw a picture of something the other day that was really interesting, but it looked like an LB, but it wasn't. And it was one unit, and it had a 90 on it, and it already had the EMT connectors built in. It was set screw. And then it had 2 screws on there that had a little cover on it where you could take the cover off and get to it.
Yeah.
I hadn't seen that before. I was like, now see, there's an example right there, somebody that's using something as a pull point because you can get to it. And the other thing,
I mean, is that really a pull point though? Like literally us being badasses in industrial, are you literally going to have the room to pull that conductor out of there and then feed it back through there? I mean,
it was pretty good size. It looked like an LB. That's why I say it. I didn't have a problem with it.
All right, cool. Yeah, I'm saying there's some that I would not consider a pull point. I would say you have to install it as a complete raceway. You know
and
what
see,
I mean?
That's another thing I was about to bring up, because then you get into looking at it as a complete raceway, and then you got to support within, depending on the wiring method, within so many inches or feet within that wiring method. Now you're going to this is what I argued. I said, if I had a transition fitting there, I'm going to have to pull that apart with something that's already supported on both ends of it. And
dude, it gets even deeper when you start going into 2-hour fire ratings. Now
Sure.
you have to be supported on within 12 inches of each side of the 2-hour rated fire assembly.
That's right.
So it
And how are
doesn't
you going to
matter.
get that apart to where you can? I mean, that just doesn't make
Yeah.
any sense to me. I don't.
Yeah.
I know who made this statement, and I know another guy that was arguing with him saying, nah, and he knows what he's talking about too. And I agree with the one person that was arguing the point about it being a pull point.
And he might have been a guest on our show.
He was. And good job, Derek. But
hey, I want to give a shout out to Kevin Muller too, because I see him every now and then, and it's really awesome. I was really glad to have him on the show. It was really awesome. He provided a lot of good input for this show.
awesome.
It was a lot of time.
When you look at it, that is my whole argument over this. And I found it very, very interesting that here's a change that just happened to take place in the 2023 that's exactly saying what I was saying. And so now that's the way it is going to be explained in our new code change book, that you do have transition things. Those are fine, but it's not a pull point. And then we show what are type of pull points that you would go to. And then we show a different type of connector that could be used as a pull point also.
Well, yeah, and the one thing that we run into all the time is that these guys say, "Oh, you know what? Inspector went up on the roof and failed my whole entire rooftop because I used GRC transition fittings." And to me, that I don't know that how that's gonna not go away. Like they make listed transition fittings that
Sure
go
they do.
like we just showed, that go from waterproof EMT to seal tight.
Mhm.
So to me, for an inspector to fail you on that, I don't think it's unreasonable. I mean, I'm like, okay, well, why didn't you get the correct listed product for that?
Yeah,
You know,
you need a product that is, I'll say, identified for that type of installation.
oh, that's another change for 2023.
Yeah. And that, you know how I am with terminology. And
Yeah.
that's why I'd say you would look at that and forget the listing and labeling. Is it identified for that? And somebody will say, oh, that's got to be listed. Let me ask you a question. Is all the connectors and couplings and everything all listed?
Yeah, and see, the thing is, when you get into it, like this is where your catch-all is going to come in. So let's just say you have a EMT connector. It's listed for rain tight. It's listed weather tight. Now you have a GRC coupling. That's listed for weather tight. That's not going to be weather tight. Now you have a seal tight connector. That's listed for weather tight. Now you put them together. That's not a weather tight listed assembly because the threads don't match.
No.
So, that's what I'm saying. When you get these listed assemblies, they match. Everything matches, and there's no argument.
You know what it sort of reminds me of? It's like the ones they were arguing with me on the outlet at the AC unit. And I said, okay, let's say it's an outlet. I said, is that a weatherproof outlet out there? And they're like, what's that got to do with it?
Dude, that whole thing is such a mess. Like I talked to some top Colorado people. I got some friends in high places out here in Colorado, and they're like, dude, we don't even know what to do. They're like, one day they said the IEI interpretation was that it's an outdoor outlet, so we need to enforce Class A protection. Next minute they say, oh, well, if it's a split system, then don't do it. And so then they're like, okay. And then I says, hey, can you just interpret it that that's not an outdoor outlet? They're like, hell yeah, you're genius, bro. I'm like, okay, that's really not that hard.
It's not that hard.
Because you don't need an amendment. You don't need to change anything. You just say, hey, that's not an outdoor outlet. Now, honestly, I would be like really sad if I went and wrote a code reference and then found out the code reference that I wrote it for was not being enforced. But that's the reason that you write good code language.
I agree. I am curious, where are they identifying the outlet now?
it's back at the disconnect again.
So they
It
changed again.
went disconnect, then the equipment, then back to disconnect. Then I think it was like the GRC coupling in the unlisted transition fitting, with the wiring method being the outlet, and then now I think it's back to disconnect again.
Well, it looks like their fitting argument just went
they
down the drain.
they kicked me out of the My Cult forum. Ah, boo! I wish I had boo. Like boo. Like whatever. I don't care. Cool. Kick me out of there. I'm just trying to add, some clarity to, interpretations and stuff. I'm not trying to call anybody stupid.
Well, I was just curious because it just keeps changing. I don't keep up with them, so I just like, okay, whatever. All right. Well, you ready to do the 5 changes for 2023?
Yes, sir. Let's get it going. Did you add metal to it?
No, I hadn't done that yet.
All right. I'll send you some metal. I'll actually play some metal for you, and I'll put it.
It may be a little bit before I do get it on there because we're so busy right now trying to get this code change book done, and all my time that's all I'm doing right now is that and getting stuff for the show podcast.
Dude, you're doing good, man. You're the first one out there as far as I'm concerned.
Well, I can tell you right now, I've already have written 140 changes.
Nice.
And I'm just in chapter 4, so I'm thinking there's going to be, I don't know what they did and all the rest, but we're probably anywhere from 200 to 250 changes this cycle.
So you know what I would do if I was you?
What's that?
Like you just do a top 100, and then the 40 you didn't get to, just throw them off in the ditch.
Well, what we do is we have them all, and then at the front of the chapter, we have the top 100 that we think.
Okay, I like it.
Tells you what we feel are the top 100.
Yeah, that is.
Okay, now last week I did everything a little fast, but I said we're going to be getting into Article 220, and we got into some of it, and I said they've moved some stuff around in Article 220, so I'm going to tell people you need to definitely get the code change book so you can keep up with everything that's taking place. And in this one, what they're talking about, this is 220.14 where they deal with all occupancies and you have other loads. And 220.14C, they made some changes here to make sure it's more specific what they want to talk about. And they're going to tell you here that the conductor sizing requirements specified, and you still got the same sections where you would go to 430.22 for a single motor, 430.22 for 2 or more motors, and then 440.6 where you're dealing with AC. And it says you will use this to determine the loads for your motor circuits, okay, or your motor outlets. And
seems like some other guys on the podcast network have been confused on that before, but not going to mention any names, but
well, they have. And the reason they did this is to provide clarity of exactly what they were specifically addressing here.
Nice.
And what type of how the calculation is being applied to. So for me, this is going to be important because this is going to clarify a lot of that calculation that's going to take place.
Okay.
So now the next one they have here is been moved. And basically what's happened here is 220.14J is going to talk about this ain't moved. This is actually added. I was thinking of 220.14J. That actually moved, and this is the section that's replacing it.
Okay.
And this is going to talk about receptacle outlets and office buildings. And they're going to tell you the way to go about calculating these loads. And it says when you calculate the loads per 220.14I, or you apply 1 volt amp per each one of those, whichever produces the largest calculated value is the one you're going to use for the calculations when you're doing office buildings. And I can tell you that is going to change a lot of our calculations where we do office and warehouse space when we're doing a full calculation for commercial buildings. And we've got I was trying to think. I think we have 4 calculations, if I'm not mistaken, and we do them all at different voltage levels. So in
Nice.
this particular one here, we're going to have to show uh, an extra portion of this calculation and how you would go and select the VA load for the receptacle outlets that are within an office building. So that's going to
Well,
be a pretty big change, especially for somebody that's taking an exam.
yeah, and I want to give a big shout out to NEC Live. We're gonna get James back on there again. He'll probably figure out a topic to do, but NEC Live does a podcast on Wednesdays at 4 p.m. my time, 6 p.m. Eastern, and their stream on Facebook. I'll be sharing it to NEC for Dummies, and we really love what those dudes' content bring. Dean Austin and Corey Hannes, great dudes in the industry. They show you how to use NEC Link, and it's a really good tool for the guys coming up trying to learn the code and stuff. So just wanted to add that in there, that we always love those guys' support for NEC for Dummies.
Yeah, I remember when I went on there and Derek was on there. I did back-to-back weeks. I did conductors and overcurrent devices, and they sent me a message, told me that of all the people they had on there, I was only one that ever cracked over 100 people to come on there and listen how to explain that.
Dude, you were more like your viewers. Like I'm watching viewers right now, and like ours is like nothing. Like yours was, dude, it was like 127, I think, at one point.
Yeah.
And so all the guys on there, they get a lot of good attention, and I could tell you, when use Stallcup. That's gonna be our new saying.
Yeah. It was funny because somebody had made a comment on one of the posts or something. I was doing something, and he said, people in the know use Stallcup, the ones that don't use others.
Yep.
I said with that, I said, hey, brother, you're going to get me in trouble.
Yeah.
So, but I did.
Hey, you can just send the check to me, and I'll make sure that all your legal fees are covered. I'm just kidding. I'm just kidding.
No
It's all
worries.
good, brother. It's all good, brother. This is our show. We could talk crap, I guess.
Okay, now where we were just at 220.14J has been moved right here to 220.41.
Okay.
And what you're going to see, it's going to talk about dwelling units or units, minimum unit load, and you're going to see the 3 VA per square foot for 1 family, 2 family, multifamily dwellings. Okay.
Yeah, and that's just the minimum. I use 6A per square foot just because I'm badass.
Yeah.
But
now,
I mean, if you want to use 3, that's cool.
Now watch some of the
you
stuff.
You can be a code minimum loser. That's fine.
They've added some stuff here to clarify, and I need to cover these. Now they tell you the unit load include the following. This is your lighting and receptacle loads, and no additional load calculations shall be required.
Right.
You see that? The only time you worry about doing something different when you're doing the VA per square foot, and you'll be looking, in this case, they just tell you 3 VA per square foot, but that table 220.12 is now moved to table 220.42. And once you take that VA per square foot, that's going to take care of those loads. Now, if you take and don't have one of those type of buildings or restaurants, schools, whatever's there, office space, if it's not listed, then you have to calculate the individual loads themselves. And we actually show that in one of our full calculations in our design and journeyman and master's books.
Yeah, and one thing I'll tell like the apprentices that are coming up, if you're going just strictly up to code minimum and you're a little bit wrong, it's gonna be more apparent because you're close, like the lights are dimming when the AC unit turns on, and people are like, oh, okay, did you do your load calculation? Like you're never gonna really get busted on these, like I still, if a AC unit turns on and the lights dim, that's still not a code violation. they're just going to question like your calculation and how you did your service calc and stuff like that.
Sure. Now, look at the last sentence here, or the last paragraph.
Mm-hmm.
It tells you the minimum lighting load shall be determined using the minimum unit load, and the floor is determined in 220.5C for dwelling units. If you remember last week, I actually covered 220.5C. That's a new section, and it talks about that how to go about determining that floor area. Okay.
Right.
Now, the other thing they put in here, and I think this is very important, it says motors rated less than the 8 horsepower and connected to a lighting circuit shall be considered part of the minimum lighting load. You don't have to calculate that load separate for the motor loads. It's already included as part of the calculation for the 3 VA per square foot.
Well, I want to give a big shout out to Thomas Dimitrovich, Mr. VA. That's what we call him, Mr. Voltamp.
Okay.
He had a few of those.
Now look what they did here. This is 220.42. That's going to take you over to the new table 220.42. Now there wasn't a ton of stuff that took place here, but one of the things I will point out once again, they're telling you to look at that floor area that's determined in where 220.5C.
Right.
And if you remember last week, I spent a little bit of time on that, and I was saying you need to pay real close attention to this. And then they took the wording that was here and put it in where we were just looking at 220.41 about if the motor's rated less than 8 horsepower, it's considered what? Part of the general lighting load.
Yeah, absolutely.
And then they tell you in the informational note, the unit values of table 220.42A are based on minimum load conditions and 80% power factor and might not provide sufficient capacity for the installation contemplated.
Right.
Okay. So those are actually big changes in stuff. And the reason that this is important, because if you're taking, especially people are getting prepped for a test, they ask you how to do a full calculation. You better know this stuff. Because these are like little trick answers they'll hit you at. And if you don't know the difference, you're not going to pass that. And
well, I'd say our track record is pretty good. I think we got 2 J-dubs and 2.
Yeah, that we're prepping for it. Yeah. And you know, what was funny is as I was going through that, one of the guys had hit me back up and he said, he said there were 2 spots in there. If I hadn't listened to what you said and what was in that program, he goes, I would have missed it because it was like a little trick answer. Yeah. And he said, when I saw it, I was like, yeah, I see what you're doing. He goes, and I calculated it just like that. He said, yeah. And, somebody always puts out there, he always says, how does he say it? How you say it? Know who's teaching it to you or something like that. How does he say it?
I think there's a lot of false statements out there. I'm not gonna get into that. I mean,
somebody said that know your audience or something, or know who.
Well, somebody said if your program's better, then they'll pay for your program. So sounds like somebody's going to be paying for your program a lot, and I don't know who it is, but it's maybe one of your competitors possibly. But
yeah, somebody said something about me, and I got text on it by somebody. I don't remember exactly what he said.
I did hear a few things about that, but at the same time, the thing that I love about your training style is that you want to make sure whoever you're teaching that they know what you're teaching, and if they don't understand it, they could come on here on Thursday night and they could ask a question and go, hey, I don't understand it.
Yeah, that's fine. I'm about to start that back up. After I'm probably going to wait just a little bit because I'm trying to get this 2023 knocked out.
Yeah, I think consecutive nights is kind of hard. We might do a Sunday maybe. I don't know.
Yeah.
Sunday night might be good.
Now, 220.43, once again, it's in 2 spots, and they're telling you the exact same thing. Whichever's the larger between the calculated load, Now, the reason they put this in there because you also have what has been moved over to table 220.47 now, and where you could have demand factors that are applied for the receptacle loads. So you still have to calculate with the demand factors, and if there's probably a possibility once you take and do the VA per square foot, it's going to be more than after you applied the demand factor. So you would take and use that as your part of your calculation.
Okay, gotcha.
Now that there takes care of the 5 proposed changes, but next week there's still going to be some more. And what I'm trying to explain to everybody, there's a lot that's taking place this cycle, and some of the stuff they're clarifying, and people need to be very, very aware of the type of questions they're asking. Because if you don't have the proper training when they do this, and you're going to take tests and they throw a motor in there for a lighting unit per se, and it's less than 8 horsepower, and you include that in the motor loads, and they do a whole bunch of them for a commercial place and say there's 50 of them, that can change what that answer is going to be. So you need to be aware of what pertains to that lighting load.
Yeah, and you got to watch it, especially here in Colorado. Colorado here, they only do about, what I understand is about 20% that are code changes for the next cycle. So good news for all the apprentices out there that are getting ready to take their exam. You could go test under the 2020 all the way up to July of 2023. So you still have a whole 365 days before you'll be on the next cycle. And the thing is that really, there's really not many that flowed in for the code change part of it. And I really like what you've done, James. And I will continue to endorse what you've done as far as the calculation part of it. There's a lot of them I didn't know. And then you are like, hey, tell me what size pipe. And I'm like, first instinct for me was like 1.5 inches. You know what I mean? Like, that's what you do. Like when you don't know, you just guess. Right. And then you're like, oh, are you sure about that? And then I was like, all right. Then I went and did all the calculations. I was like, damn it, 1.25 inches. Damn it. It still would have worked with 1.5 inches, But the whole thing was, you're testing me, and you're like, dude, are you sure you have the right answer? Because 1.5 inches will work, but is it the correct answer? Yeah. And then we went into the NEC deathmatch. Oh, I wanted to ask you, is the new questions up for the deathmatch?
No, I hadn't put them up yet. I'll put them up Monday. I've just been so swamped.
No, it's no big deal. I just want to make sure that I have a chance to take out David Englehart.
I'm not going to take him out. He's so far ahead of everybody. He's winning.
Dude, I don't know, man. I don't know. He could get a 0%. He could get a did not take because he was mad that it didn't say June on it.
I still think he's still too high.
He's up there. Yeah, he's doing great. We really love having guys like David Englehart. I mean, he's a freaking amazing, brilliant person, and it's awesome to have him as following us and stuff. So,
well, one of the things that's really, I've been very swamped because I actually had just here in Texas, I had 3 guys that didn't pass their journeyman, and they were told to contact me, and I'm not going to say who they used or anything, but I told them, I said, if you come on this one, and I actually set it up for them since they called me, but I said, I'm about to do the July 4th sale on it. I said, I'll go ahead and set it up and give it to you half off like I'm going to do for the people who are going to sign up after that. And they come on, and I had one of them text me the other day. He goes, all right. He said, I think I'm ready now. He goes, there's stuff that you're showing in there. And he goes, now I understand why I missed it. And he said, the way you have it set up in the step-by-step and with the sections table, he goes, I've actually been going reviewing where the information's coming from. And he said, I'm not only clicking through where you link in with the sections and stuff. He goes, I'm also using my code book. And he said, I'm following along with both of them, seeing the match. And he just told me, he goes, this is incredible. He goes, I have other people are going to be getting soon to get ready. He goes, and I'm telling everybody about this. He goes, this is unbelievable. And
well, and the thing is that it just teaches you how to be smart. You know what I mean? Like, that's the thing about it. Like, it teaches you to like do your own research.
sure,
Not just believe whatever. Like, because to me, that's what always messed me up was I'd believe these people's opinion. And dude, I'm not lying. I came out of a 2017 class, and I was like, "Yep, don't need a strap on, 3-foot of EMT anymore." And then all these code guys are like, "All right, well, where's the reference?" Oh, I don't have a reference. Oh, damn it, I look like an idiot, And I was like, "Oh, well, so and so said blah blah blah." And they don't care about that. They don't care what so and so said. What they care about is what code reference you back.
that's right.
And there is none. And then they're like, "Oh, well, why don't you put in a public input?" Oh, man, now I have to put in a public input for what you guys screwed up like 10 years ago? Like, that's awesome. That's awesome that you have guys putting in public inputs and doing stuff. But now all of a sudden I'm in the middle of that argument that they didn't finish back then in 2011. I mean, if it was really that big of an issue back in 2011, why didn't they put it in there that,
Right.
3-foot section of the raceway didn't need to be supported? Then cool. We wouldn't be in this argument right now in 2022.
And that's one thing, our questions that we put in there are very pinpoint, and we explain why we do the questions the way we do. But, you've heard me say this millions of times. One thing that people really get a little frazzled a little bit is when they're going to start doing the calculations. And you've heard me say this over and over and over. Calculations are not hard. You just got to know the procedure. And that's one of the things we spent the last, 30 years developing and changing.
Well,
And
one thing I noticed, if you have like 3 steps, like all your math is like super easy. But let's just say you have 3 steps, and let's just say you take step 3 and you do it first. Well, now you're gonna get an answer, but it's not gonna be the right answer. That answer will be on the test. And so they know that you reverse some steps and that you're going to get that answer, and it's not even going to be relevant. So what I like to do is I like to do reverse answer. So I like to take what you think is the right answer and then put it in the equation and then calculate it and then see if it makes sense. Because if it's not even close, then you got the wrong answer.
Oh yeah. And that's one of the things that we do is we actually will take some of our questions and have the answers sort of close together to see if you're paying attention, if you did the steps correctly. And and that's something everybody's always told us, following along with your calculations. I understand it now, and that's part of the battle.
All right, well, are we ready to do the tool review?
Yep, let me cue it up, brother.
It's time for Tool Review of the Week. Sponsored by Electricians Only Tool Review and Nipex Tradesman.
All right, well, this is really awesome to do this. These are 2 different types of crimpers, and they're the actual same type of crimper, but they do the same exact thing. They crimp ferrules, what we call ferrules, and these are actually to like reduce your size. Like if you have a large size conductor and you're trying to go into a small size terminal, then you use these ferrule crimpers. And the one on the left is probably like $50, and the one on the right is probably like $400. I don't know where they get those prices from. Like maybe the one on the right's a Nipex Tradesman. Go join today. But the whole thing is I don't get where the prices come from on that. I mean, it's really out of control. But I just want to let everyone know that we run a group called Electricians Only Tool Review, and I'm going to give a review on both of these crimpers, and they both do the same exact thing. So price doesn't mean a single thing when it comes to these crimpers. You put the crimp in there, you crimp it down, it's done. I don't see any advantage or disadvantage from using either one of these products. One of them costs $50. One of them costs $399.99.
Is the one on the right a ratchet type?
Kinda, but I think where it comes down to is the release, because the one on the right has two different methods of release. So you could crimp down to a certain compression and then you can release it, or you could go all the way tight and it'll release automatically. The one on the left, it actually does have a release. It's on the inside. You can see it kind of hanging down a little bit,
Right.
but they both have the same style features. It's just where the release is at. And I think the one on the right is more made for speed. I think it's made to where you could just, like grab it, crimp it. It's got a more comfortable grip, maybe.
Mm-hmm.
The one on the left, I would go get one right now if it was me. If I had a whole bunch of Ferrules to crimp. We don't use those too much, and I wanted to kind of just cover a little bit of these guys trying to realize that when you're using fine stranded conductors, those lugs that you're terminating those fine stranded conductors to are not rated for fine stranded conductors. So you have to take these Ferrule crimps and use these Ferrule connectors, and then that lug will be rated for that Ferrule. That's the whole reason we use these.
Okay.
But it's just a tool review that I wanted to do, and I wanted to show everyone how just because you spend $1 million on a Ferrule crimper doesn't mean anything. They do the same exact thing. They're a lot of times when you go with a high dollar one, they have like speed in mind, like where you could just really grab it good with your hand and just go really fast. And then the other one is like kind of bulky and it takes a long time to kind of grip it. And then the Ferrule is falling out and then the wire's falling out and you can't really handle it. So I think the more comfortable grip, you could get it in there, you could hold it and crimp it and you're done. But I would say both of those are equal except price.
Okay. Cool.
So yeah, that's my tool review. And if you guys do a lot of fine stranded wire, I would recommend using Ferrules and a Ferrule crimper.
I do got one announcement. I'm gonna take Sunday and probably set it up around 7 or something like that. And we're gonna do a podcast showing the Vote Online Academy, how it works and use it. Because I've actually had some people, they don't watch the video on the first screen. So I'm going to do one and just sort of go through and show everybody the power behind it. And I'm also going to show some of the new stuff that is going to be added to it for the 2023. And one of the things that we're doing for 2023, I've posted on a lot of the groups, it's called Upward.
Okay.
And basically, I'm going to, through the 2023, 2024 years, we're going to be working a lot of hours, but we're going to do as much as we can. And we're actually going to have everything where you can come in. If you're doing basic learning on electrical, we'll have that set up for you. Then we'll have intermediate, and then we'll have advanced. And basically, it's almost like going through an apprenticeship in a way, but it allows, because, when you look, you got the IEC, you got NECA or NJTC, whatever you want to call them. And there's a lot that do go to a school, but there's more out there that don't have any affiliation with any type of place they can go to get their training. So what I'm going to do is put something together that they have access to, because, most of the states, all they require is you have so many hours on the job training and everything, then you're eligible to take your German license. Well, they need to have some type of training to start at to go through their career in order to get that German. And then, it depends on the state. But like when I took mine, after I had my journeyman, I worked 2 years and then I took my master's. And, I've been prepping for that ever since was probably 16 years old. But, when I was doing that prepping during that time, even though I went through the union apprenticeship and stuff, I was actually studying out my dad's material. So,
Well, and I like what you were saying earlier about, well, not earlier, but what we talked about in other times, where you said that you were just making practice tests out of your dad's material, and then you were just going through and just answering them as much as possible and until you got everyone right.
yeah,
And to me, that's what I like to call sight learning. I'm really a big believer in sight learning. I love sight learning. And that's part of the way we're doing the NEC death match, because when you look at something, you say, oh, 50 foot from blank. Okay. You know what I mean? That's this. And you answer, and all you see is that 50 foot.
mm-hmm.
But you don't read the actual language. I mean, James knows 100%, like, my 95%, that one time I got that 95%, the one I missed was because I didn't read it all the way. And I just was like answering in a hurry, so far, I'm like second place probably in the NEC death match. And the reason why I'm second place is because I just read through it and I don't miss any. But I would be first place if I was like David Englehart and I read every single one, and then I went and like filed grievances with James and said like ones of them were wrong and stuff like that. Then say, hey, this one you didn't say under 1,000 volts, over 1,000 volts, or whatever, and like bring up like little nuances to the whole argument. Then
I
I would be at 100% right now. But I mean.
did have one question that of all of those that I've done, which is, I guess I've done about 150 of them or so now, is one of them I didn't pay attention. It was my fault. And I did the 1,000 votes or less. If I'd have put in parentheses there 1,000 votes or less, it was the same question, but there were two different answers, and you could do a different one over 1,000 votes. And I screwed up. And I was like, I can't believe I missed that. But what happens.
Yeah, so technically I had 100%, but I'm not gonna try to be as awesome as David Englehart. He's done great. And like I say, I'm pretty much been the average to beat going through the death match. I think we need to do like a lightning round. I think we need to like set up a thing and like get a bunch of people and contestants in there, and just people that haven't even joined or anything, and just do like a lightning round and just throw a bunch of questions in there from the thing. And you don't have any time. It's just basically like you just have like you have to answer it, and that's it. Like you answer it, done, answer it, done, answer it, done, like a lightning round. And then whoever comes out on that could maybe be close to David Englehart. But I think David Englehart will actually enter and then whoop your ass too. So I don't know. I mean,
I'll have to think about how to do that. That'd be interesting. But
yeah,
the great thing is the way that the learning management system set up and everything now. I don't have to ask all this information up front now. They just did a major update on it. And
okay.
now I can take and put this at the end and just ask the information at the end for your licenses and stuff like that. And you don't have to add that other information. And I had sent that to them probably 2.5 years ago, saying this would be a great feature, and finally they got that feature in there and everything. And it makes things much easier for us to do now. So, and see that's another thing that I contacted a few of the states already where they require certain information from them. And I told them we're in the process now of putting that at the end of the courses for the state license update.
Mm-hmm.
So I'm gonna have to wait a little bit on those to get approval because we were having problems on the front end, even they were. And now that I have them on the back end of the course, now they can put that information in and then I can roll. So
wow, dude, we're at 137.
yeah.
I think we outstayed our welcome with our YouTube people. I really love all our groups that are participating. We have the 2023 Code Ninjas. We have the NEC for Dummies. We have the NEC Live folks that we share their content every week. We have the Rebs group. We have all these awesome Facebook people out there that are backing us and supporting us. And we have a new one that we got on this week. It is the electrical code discussion for awesome electricians. They're on.
Mm-hmm.
So, thanks for joining us. And this is awesome to have all these people networking with us and just joining up with us. And like I say, we're trying to just bring you guys good content. That's what we're trying to do.
Yeah, I'm looking forward. I think the pace it's on right now, it's not going to be long before NEC for Dummies hits 15,000. I mean,
Yeah.
It just keeps going. I'm just like, wow. I mean, it's got to be the fastest growing electrical group because I mean, we started at the end of February or first somewhere in there, and it's already, it's just hard to believe it's grown that much.
Dude, I was totally content with 1,000 members. And that was my big thing was I only wanted members that were like wanting to learn electrical and wanting to be good electricians and wanting to do good work and stuff. So like that was the whole thing with like these other groups that have like 75,000 members. It's like, okay, well, you have 75,000 members, but most of them don't like understand what you're talking about, you know? And that's fine. I don't have any problem with engineers and architects and different people from different, people. We got David Engelhardt just popped in.
Awesome, David. Hey, David. Well, something that I think is going to be interesting as this keeps going is, it was always my goal to have people that are in the electrical industry and that belong to groups that do care about people joining a group that care about the electrical industry. David's got ECD1 over there, great group. And, David cares about the electrical industry. He cares about people learning National Electrical Code. And I like networking with the different groups and stuff and everybody, learning and trying to get on the same page. It's like I've always said, I never care if somebody disagrees or something like that. I mean, it's just a discussion. And
I mean, they seem to think I need help or something. I don't know.
Don't worry about that.
Yeah.
They said that to
I
me.
could stop anytime I want.
Well, but that's what it's all about. And I've always found it interesting. One of the reasons that it took us so long to do the online is because most of the stuff that I see out there, it's just some text and a picture. It's not an illustration. And when we started looking at all this, we tried to build it in a manner that was very interactive so the person could learn the sections, tables, and,
dude, I love the code loops on your stuff. Like if you have a question, you just go over, you're like, hey, wait, I lost you. And then you can just go over to one part of the code loop.
Yeah. Well,
and then that's the whole thing on the definition. It loops together. So you have the code loop.
It's like I tell people, they don't realize how much work went into being able to design something where you could actually work the calculations online and check your answers and stuff. And then on the side, putting that code loop, showing them what sections they go through step by step to do that calculation. All those links, interactivity and everything. I promise everybody, there is so much work involved that went into creating all of that. And when we take and do this next cycle, and I update all the illustrations in the color format. It's truly going to be a learning environment like nobody's ever seen.
Well,
Oh,
the thing
like
that I really like about your program is that it's designed to evolve. It's designed for code changes. It's designed to build. It, you're not one of those people that's like, oh, well, 2017 says this, so I'm going to just say this in all my publication. Like, you're like, oh, all right, well, it says it in 2023, so we're going to change it. And that's what I like about your thing is all your slides are like evolving. You show the text, you show the change text, you show the change text from 2017, you show the change text from 2020, you show the change text from 2023. Like, you're fine with it. You're like, okay, cool, let's do this, let's change this. Who cares? As long as we know what it is and we're out there prepared as journeyman electrician to accomplish this, and that's it. It's pretty simple.
Well, I'll tell you this, I've been contacted by different apprenticeships already, and they're waiting on the 2023 to get all the stuff in. And the way I built the formats and everything for the system, anything that I've created, you can actually go in and customize. So if you wanted just to pick this slide, this slide, this slide, this slide, and I can create that, it automatically builds my table of contents. And I could take and build say you want to do just first year, I could come to your office, sit there within, if you have an idea already what you want, we could probably build that thing in an hour or two.
Nice.
Boom, that quick.
Well, we probably blown it up for tonight, sir.
Yeah,
I
I'm
think
ready
we
to
should
go
go
eat.
ahead. We should take her out. Dude, I know Pops is probably over there freaking jawing at you.
Nah, he's in the other room. He's just waiting on me. If I stay out too long, he'll come here. Hey, I'm ready to go eat. Let's go.
All right.
All right.
Dude, awesome show, fellas. Appreciate you.
Let's take this out, and I'll send out a post for Sunday going over.
Thanks, David Englehart. Thanks, William Kurz. Thanks, all the people joining. It was a great show. I really love all the people that participated in Nat King Code, and all the people got an A+ this week. You guys all rocked it, 100% correct. We're going to have to deal with some Raceway in the Raceway next week.
We got it. We'll cover it. All right, everybody. Y'all have a good week, and we'll see. How we say it? Same bat time, same bat channel next Thursday.
Peace out from the Mile High City.
All right, everybody have a good weekend.